So you've got an Ender 3 style printer. You've heard of this thing called Klipper firmware, and it looks pretty flashy, pretty high performance, and you want to try it out. Well, you're in the right place because I'm going to show you how to install Klipper on 3 different Ender 3 control boards. An 8-bit v1.1.3 Creality board, a Big Tree Tech SKR Mini E3 V2, and the latest Creality Ender 3 Neo version 4.2.2 board. After watching this video, you should be ready to tackle putting Klipper on pretty much any 3D printer. I'll be showing you how to get Klipper onto the Raspberry Pi, how to connect your Pi to your control board, how to flash Klipper onto the 3D printer control board, how to find a config file to get everything started, how to correct some common issues with configuration, and some additional tips and tricks. Thanks very much, of course, to Creality for providing the Ender 3 Neo for me to be able to make this video. Klipper is a 3D printer firmware that uses both a small computer like a Raspberry Pi, as well as the standard MCU or 3D printer microcontroller or control board, whatever you want to call it. The Raspberry Pi handles all the calculations and any additional things like webcams and web interface, whilst the printer microcontroller just is responsible for receiving instructions from the Raspberry Pi and driving the stepper motors, extruder, heaters, etc. According to the Klipper documentation, this results in features like high precision stepper motion, best-in-class performance, and support for multiple microcontrollers, if that's the thing that you need to do. The reason I prefer Klipper over other firmware is because of things like powerful macros, input shaper tuning, web interface options like mainsail and fluid, and easy configuration of the firmware using human-readable language without having to re-flash everything every time you make a change. You just click save and restart. There are a few downsides to Klipper, like the expense of a single board computer and the setup time, but today I've got solutions for at least one of those for you, and hopefully the Raspberry Pis will be back in stock kind of later in 2023, so keep this video bookmarked so you've got it for later on. Before we get started, here's a list of things that you might need just in case you want to kind of plan ahead. Pause it if you need to. Great, let's get started. First things first, we need to get Klipper, Moonraker, and a web interface installed on our SBC or Raspberry Pi. I'm going to use them interchangeably, just imagine you can use either. They're kind of the same thing. I'm going to show you 2 different methods for doing this. The first method will be using a mainsail image, which includes everything in all one package. The second method will be using Keyua, which is the Klipper installation and update helper. I wish it was called Klipper installation updater and helper, because it's just easier to say Keyua than it is to say Keyau. Anyway, it's a semi-automatic and very controllable kind of command line interface method, but it's got a nice user interface, so it's very easy to use. There are advantages to both methods, and they can actually be combined as well. For example, you could start with the mainsail image and then also install Keyua to help with updates later on. Let's start with the mainsail image installation. Go to Raspberry Pi OS and download Raspberry Pi Imager. It's quite a small file, so that shouldn't take too long to download. Launch the executable to start the installation. This shouldn't take very long at all. Once it's done, run the Raspberry Pi Imager software. Use the keyboard shortcut Ctrl, Shift and X to open the advanced options. Change it to Always Use, enable SSH, enter the password Raspberry, or it will just use that as default, and then enter your SSID and password settings to access your Wi-Fi network. So these are just an example ones, these are not my actual settings. Change the 2-letter designator for your country to whatever it should be, and then hit save. To flash mainsail OS to our micro SD card, first select Choose OS, then scroll down to Other Specific Purpose OS, then select 3D Printing, find Mainsail OS. If you're using an 8GB Raspberry Pi 4, then choose the 64-bit version, otherwise choose 32-bit. Select Choose Storage and choose your micro SD card, which you've got plugged into your computer, then click Write and click Yes to accept. Once this process has started, it can take 15 to 20 minutes or so to write the image to the SD card. So in the meantime, I'd recommend you go and get started with step 2, as you can do most of it before actually finishing step 1. Once the writing and verification have completed, hit continue and safely remove the micro SD card from your computer. Now that you've flashed an image to your SD card, you need to insert it into the Pi and turn it on. If you don't have Wi-Fi, plug in an Ethernet cable connected to your network as well. The next step is to identify the IP address of your Pi. My preferred method is to check the list of connected devices via my router's IP address. If you don't know your router's IP address, you can use the command ipconfig from a command prompt window, and then the default gateway is the IP address of your router. Type that IP address into a web browser and eventually you should find yourself a page like this. If your Pi successfully connected to your network, it will be listed here. If you're having trouble with that, you can also use Advanced IP Scanner. This will scan your network and should find the Raspberry Pi that you've just connected to it. Type the IP address of your Raspberry Pi into a web browser and you should find something like this. The first thing we need to do is run updates, so head to the Machine tab and then scroll down to the Update Manager, check for updates, and when it's done, hit Update All Components. This process can take a little while as there could be a lot to do, but once it's done, you should see that all of these different things are fully up to date. That's our mainsail installation ready for step 2. Now I'll show you the other method using Keyua and Fluid. For this method, we're going to start the same as we did with the other one by downloading and installing the Raspberry Pi imager and modifying the advanced settings. This time we're going to flash Raspberry Pi OS to our micro SD card. First select Choose OS and then right at the top select Raspberry Pi OS. Select your storage, which is your micro SD card, and then click Write and then Yes to confirm. Once this process has started, it can take 15 to 20 minutes or so to write the image to the SD card. So in the meantime, I'd recommend you go and get started with step 2, as you can do most of it before actually finishing step 1. Once the writing and verification have completed, hit continue and safely remove the micro SD card from your computer. As with the other method, use the ipconfig command or advanced IP scanner to acquire the IP address of your Raspberry Pi. Next, connect to the Pi via SSH using the command ssh-pi at the IP address of your Raspberry Pi, and when asked about the fingerprint, type yes. Enter your password, by which the default is Raspberry. Remember, it won't show up as you type it, and then hit enter to connect. Optionally, you can use this command to update and upgrade the operating system. When that's done, use this command to install Git. Note that it may already be installed. Use this git clone command to download Keyua from GitHub. Use this final command to launch the Keyua shell script. The screen will go black and then show you the interface. From the main menu, we can see various installation statuses, and we can browse to other parts like installing and updating by entering numbers and hitting enter. First things first, let's install Klipper. So hit 1 to go to the install menu, hit 1 again for installing Klipper. Hit 1 to use the recommended Python version, and select 1 for the number of instances. It takes a while to do the installation, so some patience is required here, but when it's done, it will ask you one more thing, so hit Y and then enter again. Next, we need to install Moonraker, so hit 2 for Moonraker, and then hit Y for yes. Again, a little more waiting required. The next thing to do is install a web interface, so you need to decide which one to use. The most popular options are mainsail and Fluid. From a user perspective, they're very similar, so don't expect one to really perform better than the other. I have mainsail installed on most of my machines, but I'm going to use Fluid for this example, just so you have, a comparison. Feel free to use really whichever one you prefer. From the installation screen, hit 3 for mainsail or 4 for Fluid. When asked about adding macros, you can add them, but we're ultimately going to be replating the file which these go into anyway, so you might as well just hit no and do it yourself later. If you're going to be using a touchscreen, I'd also recommend installing Klipper screen via the number 5. Otherwise, hit B to go back to the main menu and just make sure you have everything installed looking a little bit like this. Regardless of whichever method you use, you should now have an error message something like this that says Printer.cfg is unable to open or missing, which is actually good, because that's the next step. You'll have noticed up to this point that nothing has really been specific to your 3D printer. That's because all the configuration information is saved in a special file called Printer.cfg, arguably the most important file on the printer. This file is what we need next. It can be daunting to configure this completely yourself from scratch, but it's actually surprisingly simple, and there are loads of pre-made examples to get you started, which is what we're going to be doing today. Printer.cfg is a text file comprised of these things called sections or segments, which contains a type of the segment and sometimes a name. Below each section header is a number of parameters, and each parameter has a variable associated with it. It's these parameters, variables, and sections which ultimately configure your 3D printer. One of these sections is called the include section, and we use the include plus a file name to basically reference an additional file to our printer configuration. To find a configuration file to get started, you're going to need to know the make and model of your 3D printer, so Creality, Ender 3, Neo. And if it's different to the original, the make and model of the control board that you're using. For configuring the details later on, you'll also need to know about any modifications that you made to your printer, such as maybe changing the hot end. For this demo today, I'm going to be using 3 different control boards. Firstly, the Creality V1.1.3 board, which is an 8-bit Atmega 1284p, originally found on the first Creality Ender 3 printers. The second is a Creality 4.2.2 board, which is a 32-bit ARM-based board that's found on the more modern Creality printers. The last one is a BigTreeTech SKR Mini E3 V2, which is a 32-bit ARM-based upgrade board for, again, mini Ender 3 style or Creality 3D printers. The main place to look for a configuration file is the config folder of the Klipper GitHub. These are arranged by printer or by control board. The other location you may want to look is the website or GitHub page of your control board manufacturer, as they may have a kind of detailed and pre-made configuration specifically for the 3D printer that you've installed it on. Starting with the old Creality 8-bit V1.1.3 board, we're going to drop into the configuration folder and use Ctrl F to have a search for printer-creality-ender, and we should find the Creality Ender 3-2018.cfg file. Open that file and then click Raw to see just the code, right click and Save As. Remember to remove the .txt file extension from the file, you just want it to end in .cfg, and save it in a knowable, memorable location. Optionally, make a copy of the file and rename one of them to Printer.cfg. Access your printer using the IP address via the web interface as you did before, browse to the machine or configuration section, and upload the Printer.cfg file. Once it's uploaded, left click to open it and add a new section, so square brackets, include fluid.cfg. Click save and restart, and that's it for step 2 on the Creality V1.1.3 board. For the 4.2.2 board, we don't have an Ender 3 Neo configuration pre-built, so we're going to start with one from the Ender 3 V2, which is obviously quite old now, but it does actually use exactly the same control board, so it's a great starting point. Save and rename the file as printer.cfg, browse to the IP address of the Raspberry Pi, go to the Machine tab and upload the printer.cfg file. Left click to open the file and add an include for mainsail.cfg. Save and restart, and we're done with this config for now. For the SKR Mini E3, since this is an aftermarket control board rather than one out of an original printer, we're going to be going for a generic control board based configuration file. In this case, the one specifically for the SKR Mini E3 V2. As with the others, save the file, rename it to printer.cfg, upload it to the Raspberry Pi, open it, and add the include for fluid.cfg. At this point now, you should have your Raspberry Pi successfully running Klipper and a starter configuration file. Next, we need to connect the single board computer, aka Raspberry Pi, to the control board of choice, both using wires and within software, so let's do that. Up to this point, connecting your Raspberry Pi outside of the printer to any old power supply would have been fine. For installing it inside the printer though, I'm going to be using ElectroPi. This is a 24 volt to 5 volt 5 amp power converter specifically designed for single board computers like the Raspberry Pi in industrial applications. Simply connect 12 or 24 volts to the power input and 5 volts will be supplied to the output. Starting with the Creality V1.1.3, connect it to the Raspberry Pi using a USB cable. Start an SSH session to the Raspberry Pi like we did previously, then launch Keyua using this command. Type the number 4 to go to the advanced settings, and then 4 again to go to the build and flash menu. Using space and the arrow keys to navigate, change the processor model to Atmega 1284p, and then hit escape to exit and Y to save. At this point you have a minute or so to wait while the Raspberry Pi creates the firmware which we're going to be putting onto the printer control board. Type 1 to use the regular flashing method, type 1 again for USB mode, and then whatever number for the correct MCU. Ideally it's 1 for the only one connected, and then press Y to confirm. Flashing the firmware should only take a minute or so. Once it's done, type 5 for the get MCU ID and then 1 to select the USB interface. The MCU ID will be shown on screen, which we need to move into the configuration file. So highlight it and right click or Ctrl+C to copy. Open up the Raspberry Pi's web interface, go to the configuration section, open Printer.cfg and find the MCU section. In the serial parameter, change it to dev serial by ID and then after the /, paste in your MCU ID. For our 2 remaining control boards, these are both 32-bit, and as a result, there are more configuration parameters to get right when configuring the firmware. These are different for every make and model of control board, so it's really important to get it right. The information that you need is typically kept in the top few lines of the configuration example files for that specific control board. Focusing on the Creality version 4.2.2 board, start by connecting it to the Raspberry Pi using a micro USB cable. Since we've already done it using Keyua, this is a more manual method of how to create the firmware and flash it to your control board. Start by using SSH as we have done before to connect to your Raspberry Pi. Use the cd command to change directory to the Klipper directory. Then run the command make menu config to start the configuration options for the firmware. Using the arrow keys and spacebar to navigate, enable the extra low-level configuration options. Change the microcontroller architecture to STM32. The processor model is already set correctly. Change the bootloader offset to 28 kilobytes and the communication interface to serial on USART1 PA10/PA9. Press escape to close and Y to save. Enter the command make and your firmware will start to be created. This takes less than about a minute and you'll know it's done when you see clipper.bin at the end. We can't flash this board directly over USB, so we're going to use WinSCP to transfer the firmware file from the Raspberry Pi to a computer and then from there onto the control board. Open WinSCP and in the top left corner hit New Session. The host name is the IP address of your Raspberry Pi, the username is Pi and by default the password is Raspberry. Click Login to start the session and Yes to accept the certificate. Browse to the directory home/pi/clipper/out and copy the clipper.bin file over to the left-hand side, which is your local machine. You can then move it from your local machine onto the micro SD card. Plug the SD card back into the control board and reboot. Now start an SSH session, just as we have done before, and then run this command to get the MCU ID. Highlight it and then use Ctrl+C to copy. Go to the web interface via a browser and open up Printer.cfg, find the MCU section, and paste this in the serial parameter. Click save and restart, and once it reboots you should start to see some data about the printer such as the extruder and bed temperatures. Lastly, the Bigtree Tech SKR board. Start by connecting the Pi to the control board using a USB cable. Start an SSH session to the Raspberry Pi like we did previously, then launch Keyua using this command. Type 4 for advanced and 4 again for build and flash. In a separate window, I'm going to open the Printer.cfg file to double check the parameters we need for the firmware. So enable extra low configuration options, change the microcontroller architecture to STM32, change the processor model to F103, it probably is already set to that, change the bootloader offset to 28 kilobytes, and finally set a GPIO startup pin to !PA14. Escape to exit and Y to save. While the firmware is being created, make sure you have a micro SD card inserted into the control board. Type 2 to update via SD card, 1 to connect via USB, 1 again to select the MCU, and then Y to confirm. And then find your control board in the list, in this case it's number 21. Leave the baud rate at the default of 250K. The Raspberry Pi will then send the firmware off to the SD card that's in the control board, restart the control board to get it to read the SD card, and then your firmware will be flashed. You'll get a confirmation message when it's finished. Next, type number 5 to get the MCU ID, 1 for USB, highlight the MCU ID that's shown and Ctrl+C to copy. Open up your web interface, find the MCU section and paste the MCU ID. Save and restart and your Pi and control board should now be connected. At this point, you should have your Pi running Klipper firmware and your 3D printer's control board connected to it. However, since you're only started with a basic configuration file, there may still be some errors and we'll need to also flesh this out with kind of the other features that your printer has, like an LCD screen, touch sensors, etc. You've probably noticed at this point that of the 3 control boards I have, only one of them is actually in a 3D printer. As a result, I won't be able to fully test everything for 2 of these boards, so just bear with me on that. For the Creality version 1.1.3 board, we have just one issue to solve. The problem is that Moonraker, which is the API for Fluid, is expecting a different G-code path to what it's been provided. It does tell us the solution though, so let's fix it. Start by highlighting and copying the new path that we need to use. Head over to the configuration section and open fluid.cfg. In the virtual SD card section, paste the new path over the old one. Save and restart, and once your printer restarts, it might show the error for a bit, but once it connects, that should disappear. And then you can head over to the dashboard where you'll see temperatures, movement controls, the console, and other stuff like that. Moving on to the Creality version 4.2.2 board that's controlling our Ender 3 Neo. We have a few more things to solve before we have a fully working printer. For example, we need the screen to work, we want the Z probe to work or the CR touch, and mesh bed leveling using that automatic probe. Starting with the screen, we're going to head back over to the Klipper GitHub, and in the config section we're going to look for sample-LCD. This contains a list of sample configurations for LCD displays. If we look for the Creality stock display, we'll find a configuration setup, so we can copy that and paste it into our Printer.cfg file. The only problem is, this uses pin aliases rather than actual true pin numbers. So, back to the Klipper GitHub we go, and this time looking for version 4.2 board, which will have pin numbers for the specific configuration we're looking for. Here we can find the board pins aliases, and you can see that contains pin numbers for the expansion headers, as well as a few other pins. So we can copy and paste that into our Printer.cfg. I'm also going to add the display status section, which enables the use of M117 commands. After a quick save and restart, the printer boots up and the screen now works exactly as we want it to. Now let's work on the Z probe, aka CR touch, aka BL touch. Again, we're going to pop back over to the Klipper GitHub, and in the config section we're going to look for Ender 3 S1, as this is a printer which also has a BL touch sensor. In there we find BL touch, bed mesh and safe Z home sections which we can use as a starting point by copying them into our Printer.cfg file. First, let's change the X and Y offset to match the position of the probe relative to the nozzle. Next, we can copy our board pin aliases for the probe in and probe out to the sensor pin and control pin respectively. Also, change PB0 to out and PB1 to in, otherwise they're the wrong way around for some reason. Next, we need to change the stepper Z end stop pin to probe Z virtual end stop, and that will make it use the probe instead of a Z end stop. We also need to comment out position underscore end stop, as there obviously isn't an end stop position anymore. We also need to add a position underscore min to the stepper Z section, because sometimes during probing the Z can go slightly below 0. Because we need to ensure that the probe hits the bed when we do the Z home, we need to ensure that the probe is in the middle of the bed when that happens, or at least close to it. For this, we use the safe Z home segment and an appropriate home XY position. To calculate this for each axis, take half the size of the bed and subtract the nozzle offset. By default, the minimum position and home position will be the same thing, which is not really ideal. We'd quite like 0, 0 to be right in the corner of the bed. So to do this, we home the printer, manually move using the web interface controls to the corner of the bed. We then take those numbers where the nozzle meets the corner of the bed and set those as our position min for X and Y. Lastly, let's enable the bed mesh by setting the mesh min and mesh max to appropriate corners of the grid. Remember, these are the probe positions rather than the nozzle position, so it's important that you can make sure your printer can actually get to these positions without crashing. Changing the probe count will allow you to change from such as like a 3x3, 4x4, 5x4, whatever type of grid that you're looking to probe. One last save and restart and we can test things out. Always do this step by step, just one axis at a time at slow speeds to make sure it's going in the right direction and that the end stop responds as it should do. Keep your finger over the emergency stop button just in case things don't go well. Most importantly, never let the hot end and probe get to the bed until you're absolutely sure that that probe is going to work when it touches. Basic movement and homing seem to be all working, so let's try a bed mesh. While I totally missed this shot with the camera, the printer seems to be working just fine and this bed mesh looks reasonably good in terms of its functionality. The resulting mesh is definitely not perfect, but it does indicate it's working. It's probably worth me leveling the bed so that the auto compensation doesn't have to work quite so hard. Moving on now to the Big Tree Tech SKR Mini E3. We did have this same Moonraker issue, but I already showed you how to fix that with the other configuration, so let's do more important work. Because we started this with a board configuration instead of a printer configuration, we need to ensure that we have the correct parameters for a 3D printer. So I'm going to download the configuration file for the Ender 3 2018, and I'm going to compare my printer configuration to the board configuration and transfer any values which I feel are appropriate to transfer. The things we're looking out for are things like the size of the axis, the steps per millimeter, the parameters of the heater or thermistor, and particularly the extruder, as that's obviously going to determine the amount of plastic that comes out. The only real thing missing is the configuration for the display. So the sample LCD config file in the Klipper GitHub is what we need to find again. From there, we need to find the stock Creality display and copy that section back into our Printer.cfg. As always, don't forget to save and restart. Everything seems to be working now, so that's all we have for this board configuration. So that's our 3 different configurations on 3 different control boards using a variety of methods. Now, I'll run through some additional tips and tricks which you might find useful during your own configuration. If one of your stepper motors is rotating in the wrong direction, open Printer.cfg, scroll to the stepper motor segment which is a problem, and put an exclamation mark in front of the direction pin. When shutting down your printer, you should always use this control in the top right corner before you turn off the power button. By adding these 2 short sections to your Printer.cfg, you can show the Raspberry Pi core temperature as well as the MCU temperature on the main dashboard. This will also allow you to use these as sensors that can control things like fans, for example. Using the settings menu in the top right corner, you can add a name for your printer and call it pretty much whatever you like. In the same menu, you can also get to presets, which are basically temperatures you can set for preheating to specific materials. And this gives you a very easy access button on the dashboard. And the last trick I want to show you is that you can home much faster by adding a second homing speed. You can then set the primary speed to being increased speed and then the second one being slow. You'll get a fast time using the first speed and an accurate probe using the second speed. Increase the max Z velocity if you need to. This video is already pretty long, so we don't have time to check them out here, but you'll also want to have a look at input shaping and pressure advance to improve your print speed and quality. The last thing I want to cover is updating, because over time you will need to do updates. Luckily, it's really easy to do. If you're using Keyua, go to the update menu and select A to update all. If you're not using Keyua, then go to the configuration or machine page from the web interface, press the refresh button to check for new updates, and then press the update all components. The amount of time it takes to do the update will be based obviously on how many updates there are to do and how big the updates are to download. One thing you will need to watch out for occasionally is when Klipper goes up a significant version. At that point, you'll lose communication between the Pi and your control board, but don't worry. All you need to do is make a new firmware on the Pi and flash it to the control board. This is pretty much what we covered in step 3, so you can basically just go through that. You won't need to do the MCU ID thing again though, that's already done. This won't affect your Printer.cfg file, but I recommend making a backup before updating, just in case something unexpected happens. Don't forget to check the links in the description, and I'll see you in the next one.